So I want to teach you guys how the Richter scale works. Okay? You guys heard of this thing?
The earthquake scale?
Yeah, that is the earthquake scale. So the way the earthquake scale works is it measures the amplitude of an earthquake. So first we should note how earthquakes work. Oh, maybe I should have the second table. Okay. So this is, I'm going to describe to you what's called a thrust fault earthquake, I think.
We're in math,
Yeah, I know we're in math class. So what I'm going to do is I'm going to line up a couple objects on the tables here. Object, object, right? Think, draw a line on ground.
Draw a line on ground.
Right? So you have lines spray painted on the ground. Then if there's an earthquake, how does an earthquake work in something like this? Yeah, there's some kind of like slipping, right? So the earthquake might do this. Let me line my stuff out a little further so the wheels work nice. So an earthquake might look like this. Right? So what we're going to measure to figure out the Richter scale is we're going to measure how far the maximum displacement was. Okay, see that? That's what we're going to call the amplitude of the earthquake. And if it's a wave, right, like if it's a sine wave, maybe that decays off a little bit, right? That amplitude is going to be the height of the biggest bumps, right, divided by 2, right? The distance between the kind of beginning and end divided by 2. You guys with me on that?
Yeah.
Okay, so we're going to measure that amplitude in some units. It doesn't, for the purposes of this lecture, matter what those units are. Okay? And then we're going to take the log of the answer we get. Cool. So in equation land, that's going to be the Richter scale is the log of the amplitude, and the amplitude you measure in 10 to the minus 6 meters. Cool?
What's the name of this chapter?
What's that?
Is this in a chapter? Or?
Yeah, in your book, this is in section 5.2 or 3.
Okay.
They're both applications of logs. So one's kind of population stuff, and the other one's like pH and decibels. And okay, so what I would like to illustrate is that every point on the Richter scale is going to correspond to what?
To the displacement.
Yeah, to some more displacement, right? So if a 1 looks like this, and this is actually a little bit hard for a 1, what's a 2 going to look like? Nice. Because it's in the logarithm, right? It's another power of 10 to get a point. You guys see that? So the difference between a 1 and a 2 is a factor of 10 in amplitude, right? So this is going to be a 2. Well, 2 might be more like this. And a 3 is going to be
100 times a 1.
100 times a 1 or 10 times a 2, right? So that might look like this, right? And 4 would be actually quite a bit, right? And a 5.
How strong
Right? And a 6? Yeah, just don't in the building, right? And a 7?
Buildings coming down.
San Francisco.
Buildings are definitely coming down. So let's line out some ideas in here, right? So if we're going to think about the Richter scale, right? 4, 5, 6, 7, 8, 9. What does the Richter scale go to?
10. 11.
Yeah, a lot of people think it goes to 10 or 11. The Richter scale doesn't actually have a limit. Right? It's just how much of those two things get displaced. It has a nice convenient physical limit in that the Earth only has a certain diameter. Right? And so if you have an earthquake strong enough to score a 15 on the Richter scale, right? There's some chunks that are going to be displaced. right? And then you're going to have stuff like gravity's going to start to come into play in like wild ways. So there has been one event that's well above a 10 that we know of that occurred on Earth, which is not Nibiru, despite popular mythology.
Does it have anything to do with the Anunnaki?
It does not, as it turns out. It does have something to do with the friggin' moon. No, the real moon. Not the hologram that they project over the top of it, but the actual moon.
The one we actually landed on or pretended to land on?
The one we pretend, I don't know.
The one we're going back to? Or?
Anyway, the moon, the point is, was at one point a chunk of Earth that got split off by an impact a long, long time ago, which is one of the reasons that the moon is weird. Do you guys know the moon is weird?
No?
What's the weird thing about the moon?
It's cheap.
The crater?
It says it rotate on an axis.
I mean,
The way it rotates on its axis is weird. It's got one face that always faces towards the Earth.
Oh, the dark side of the moon.
Yeah, because there's actually a dark side of the moon, a side of the moon that we don't see. It's not that it never gets light on the back. Right, it does. We just don't ever see it because we're stuck on this side. That's weird. Most moons don't have that. Most moons you can see the whole thing as they spin around, which is one of the reasons that early humans were very confused about what the heck the moon is. Right? Because if it was round and spun, it seems obvious that you would get to see the whole thing sometimes, but you only ever get to see half of it, so weird. Okay, anyway, point was, what should a 1 be in terms of things you feel like? I'm just trying to sketch out basically how destructive you expect these to be.
Well,
So, has anybody been in a 1?
Yeah.
Yeah, you've all been in a 1.
Yeah.
Well, at what point would you think that a normal person would wake up?
4. 4 is
Like if you were asleep
Attention,
and
I'd say
attention,
like a 5.
attention. Due to inclement weather, Columbia College is closing the campus. When exiting the campus, students are asked to please observe the instructions of personnel directing traffic.
There we go.
Those waiting for transportation may come to the Manzanita Building Rotunda. For the safety of our students, staff are required to clear their areas and report to the Manzanita Building Rotunda for further instructions.
I get a job!
For information concerning the reopening of the campus, please call our campus conditions hotline at 588-5100 or check the college website.
dangerous zone right
Okay, hang on. Give me 2 seconds. Come on, we just got a snow day. I'm really excited, but I want to finish this.
Yeah, sure.
So, 1s you're not going to feel. 2 you're not going to feel. 3 you might feel if you're awake and paying attention. It's going to feel a lot like...
Attention, attention, attention.
Stop
Due to inclement weather, Columbia College is closing the campus.
telling us that we
When
need
exiting the campus,
So, it's going to... A 3 is going to sound a lot like a bad spin cycle on a washing machine in a neighboring apartment.
You're gonna.
Like you'll feel it a little bit, but it's not gonna knock anything over. It probably won't even put pictures off the walls.
Yeah, like you'll see the dishes shake or something. Okay, that's about it. Do you still want 5.1 today?
Yeah, I still want 5.1 today.
Okay.
4 should be.
You'll feel it.
4 you're gonna feel stuff will start to like fall off the walls if it's not on the walls very well, but it's not gonna hurt anything. 5's gonna start to break stuff.
Yeah, place
Like, it's going to break windows. It's going to be a little hard to stand up in the process.
attention, attention.
Okay. 6s are going to start to knock down poorly constructed, medium constructed buildings. 7's going to start to knock down hardened buildings. 8's going to knock everything down. 9s are going to flatten huge amounts of area and will knock down like bunker kind of buildings. You don't want to be around for a 10.
The largest recording was 9.5.
9.8s, I believe, have been recorded under sea.
Oh, under sea.
But yeah, the largest land-based earthquakes have been like 9.4, 9.5, and they're a big deal.